Hello, this is Dean Palmer, and I will be going over the bin packaging problem. Let's get right into it. Problem description. Bin packaging is a well-known problem in the area of contributional optimization. This problem considers packing a set of items into a number of bins such as the total weight of the bin's volume does not exceed some of the max values. This is an NP-hard problem. The following is a list of approximate, so that's talking about the algorithms it uses. The first fit, best fit, first fit decreasing, and it also used the best fit decreasing later. Analytical model. The proposed analytical model is effective for the given decision problem, making problem DSS, because it answers all the questions in the DSS Word document attached. GUI usability. One of the nicest features with this program is that the user can adjust the size of the bins and the weight of the objects to see how this affects the graph. By choosing the best part of the graph, they can make sure that the least amount of space is unused and that the maximum amount of bins and volume is used. By doing this, the user can easily see what weight is the optimal size and weight that they are capable of creating. The impact of this project. This project has an impact of manufacturing or shipping companies. Manufacturing companies can decide how many products they need to package together so they can fit as many packages on a commercial truck as possible to optimize the space, to use the least amount of money to pay the shipping companies. Shipping companies can use the program to suggest what size packages manufacturing companies should use for the optimal cost to ship those products. So I'll get right into the VBA Excel part. This is the welcome page for the Excel. I'm going to start by going into the code behind the Excel program. So we'll go to Visual Basic. Well, I'll actually start you on Module. Okay, so these are the things that are going over the overarching program. So these first two are just showing the worksheets, because to show and hide worksheets you need to do it in the module. And then for user forms it's a little different, so I'll go through that later. But this is to show and hide the going back and forth to the welcome page. This is to go back and forth from examples to objects. This is go back and forth or back to objects from examples. This is to show the second user form when you click the flowchart magnet disk. That's to show the charts. And this is just DMing all the objects that I use. Alright, so I'll go into the first user form. Okay, so this first user form is what pops in as soon as you click that start button. Total number of bins available, size of bins, and objectives to be packed. There's some code behind the cancel button. I'll show you that, and this is the last time I'll show. This is just to hide the first user form. Later it will go into how to hide and show other forms. If you were to click cancel to go back to the old form. Okay, so this one has a lot of code behind it. Alright, so at first it just DMs. This is right here. This is just an error check to make sure that there's no blank spaces left in any of those boxes. And so moving on from that, this is to hide and show the welcome forms. So yeah, this is for the sheet part. And this one just clears the range, because once you enter this in, you're going to want to clear that range in case there's any other data from the previous user. So you can enter in your own data. This is to clear all the cells next to all the numbers. So you're going to say a number of bins you want to enter, so 1 through 100, doesn't really matter, and then it'll make the next cell next to it a blank space. This does not end up working. It only makes that first cell blank space, but as far as I checked, it should make that work. Okay, so this is just the command button to hide, and this is user form 1. Yeah, so this is making so the value you enter for user form 1 also comes in later for a user form for the bin size new. So the bin size makes it so you start out with that same number that you put into the first sheet. So we have, for the algorithms, we have first fit, best fit, first fit decreasing, and best fit decreasing. So I'll show you the cancel button really quick. That's just to show and hide this form, and so to hide this form, go back to the first form if you want to cancel, and then, yep, so that's exactly what that does. And then the solve button has a lot behind it. This has each one of the algorithms in it. So I'll start with first fit. So I couldn't get this to work. I couldn't get it to work on my own. I thought the code looked better for a, I think this is a Python code. But yeah, so this doesn't have anything to do with my variables, but I couldn't get anything I tried to work. Obviously the code's very complicated. For the second one though, this is yeah, this does work for the this second one for the best fit. This does work, and it dims some of the variables at first, mostly as doubles. Then it activates the chart because it wants to use the chart. And then use the worksheet function. So the formula is down here. Sets its x value. That's and sets its a value, x b, x and c. So those are all the different weights and stuff that you would use, and the number of objects and such. Then here's an error check in the formula. This also I tried to get to work a bunch of times, and every time it showed up with an error. So case best fit, decreasing. That's what the D stands for. This is in Excel, but I was a little farther off of getting to work. So yep, and then I obviously missed one. So yep, case first fit decreasing also. This one I think was also in a different language, maybe C++. From looking at the code, I couldn't get it to work as well. So moving on, this is just the cancel button. So that's all of the stuff in this one. So just pretty much using the algorithms. So going on to user form 3. Okay, user form 3, it should use the size of bins that you originally created and the weight of objects. That would be created actually new in this. That would be just increasing its W value. This graph, once you create graph, should make the graph create. But as you can see in this, I couldn't get it to work. I tried a bunch of different things to load the picture, but it wouldn't pop in. So, and then behind these buttons, these are connected. So you had to spin down, spin up. I just connected that to bin size new, which is the variable it uses. For the other ones, the weight value, it also uses those spin buttons. So those are all connected. So I'll show those later. So that's pretty much everything in here. The cancel button is the same. And create graph, I showed you that. So all right, total numbers of bins used. This would show you how many bins were used, but since the algorithms weren't able to work, that didn't end up using an unused spaces in each bin. That's very important to see how optimal the program is. And then when you click end, it just kind of hides everything. So now I'll go over how to use the program and how it runs. Start by just getting out of this VBA window, so just minimize that, and then you have the begin button right there. So you click begin, and it shows that total number of bins available. If you just put in 5, say you put in 5 and you click submit, it won't work because you need all the variables. So click 5 again, submit, goes on to this one. That's that code I was talking to you about. So we have a normal for loop that just goes through all the numbers you could possibly put in, and then this is supposed to make each one of these a white space. I showed that code earlier. For some reason it doesn't work. So the Word document asks for a see examples button. So I have the examples. All this is just pretty much the minimize function to try to get it to work. Use this function to make your pseudocode, and then this is just showing the algorithms that it wants you to make. So first fit, best fit, first fit decreasing, best fit decreasing, and then this is a great YouTube link to show some code that runs really well, and honestly I think is better than how the Word document wants to show. It has a ton of different graphs, and you can actually click things, rearrange it, because it has a ton of like just different applications. So it's super nice. So I suggest watching that. If you click this back button, of course you go back to the beginning. You need to resubmit that. I'll just show you that the for loop does work. If I put in 20, it should pop in with 20. So we're gonna see examples. So we'll click solve the problem. You click the algorithm you want to use. I think best fit would honestly show up the best. So size of bin, you can click up or down. It just decrease by 1. So, and that would change the graph that you had. So right now we had 20. So if I wanted to go just a 18, I could have that. And then you have the weight of the bin. So how much those variables depend on that. It looks like that button's not working right now. You create a graph. That doesn't work, but that'd be super nice. I think, yeah, for some reason that's connected to that. Okay, so then you click reports. Then that would pop in the total number has been used in the unused space for each bin, and then you go cancel and just go back to that. You go back to that. So that's how the cancel button works too. So some lessons learned from this project is using code using online code is key when developing complicated algorithms. I couldn't have done it without it. Projects assigned in class have real applications for real world problems. This is because my the person renting my apartment from my father, he actually we were trying to pack his he rented a U-Haul pod, it's called, and we were trying to pack that in. I was just talking to him about how like what I was working on in class kind of applied to it, trying to get the tightest fit in most boxes in there. And getting an early start on a project is key to realizing the amount of time needed to complete that project. So, thank you.